So remember when we talked about linear equations and how they can be written in the form ax plus by is equal to c, where a, b, and c are real numbers? Well, a linear inequality is similar, but instead of having an equal sign, it has a less than, greater than, less than or equal to, and greater than or equal to sign. Now suppose we have the equation x minus y is equal to 2. If we graph this equation, it will look like this. We know that every point on the line is a solution to the equation, including 4, 2. But what about the inequality x minus y is less than 2? If we plug in the ordered pair 4, 2 into the inequality, we get 4 minus 2 is less than 2. This simplifies to 2 is less than 2, and this is a false statement, which means that the ordered pair 4, 2 on the line does not satisfy the inequality. Let's try a point on the right-hand side of the line, 8, 2. If we plug in the values into the inequality, we get 8 minus 2 is less than 2. This simplifies to 6 is less than 2, which is also false. Now let's try points that's on the left-hand side of the line. If we check the values, we get negative 6 minus 4 is less than 2, which is true. Negative 8 minus negative 4 is less than 2, which is true. And 6 minus 8, which is also true. This means that every point on the left-hand side of the line satisfies the inequality. So we indicate this by shading in the area. Now because the points on the line does not satisfy the inequality, we denote this by graphing a dashed line instead of a solid line. Now, what about the inequality x minus y is greater than 2? If we check some of the points on the right-hand side, we get 8 minus 2 is greater than 2, which is true. 8 minus negative 4 is greater than 2, which is true, and 2 minus negative 8 is greater than 2, which is also true. So we can say that the ordered pair found on the right-hand side of the equation satisfy the inequality. We can show this by shading in the right-hand side. Again, because the solution on the line itself does not satisfy the inequality, the line should be a dashed line. Now, if we wanted to include the values that are on the line, we would use the less than or equal to sign or the greater than or equal to sign. For example, if we have the inequality x minus y is less than or equal to 2, this means that x minus y is equal to 2 or x minus y is less than 2. So we would graph a solid line, not a dashed line, and shade in the half plane x minus y is less than 2. On the other hand, if we had the inequality x minus y is greater than or equal to 2, this means x minus y is equal to 2 or x minus y is greater than 2. So we would graph a solid line and not a dashed line and shade in the half plane x minus y is greater than 2. Let's do some examples. Let's graph the inequality x plus y is less than 5. So the first thing is to replace the inequality sign with an equal sign. Now, to graph a line, we only need to know 2 points. Using our understanding of x and y intercepts, we can see that when x is equal to 0, y is 5, and when y is 0, x is 5. So with these 2 points, we can graph a dashed line. Remember, if the inequality sign is a greater than or less than sign, we graph a dashed line. If the inequality sign is a greater than or equal to sign or a less than or equal to sign, we graph a solid line. Now let's choose a point that is not on the line as a test point. Let's choose the origin, 0, 0. If we substitute it into the inequality, we get 0 plus 0 is less than 5, or 0 is less than 5. This is a true statement. This means that we can shade in the half plane that contains the test point. Let's do another example. 2x minus y is greater than or equal to 6. We can replace the inequality with an equal sign. Then we can find x and y intercepts for the equation. If we let x equal to 0, y will be negative 6, and if we let y equal to 0, we get x is equal to 3. With these 2 points, we can graph a solid line that passes through the 2 points. Now choose a test point. I'll choose the origin for simplicity, 0, 0. If we substitute 0, 0 into the inequality, we get 0 minus 0 is greater than or equal to 6, or 0 is greater than or equal to 6. This is a false statement. This means we can shade the half plane that does not contain the origin, just like this. Now pause the video and solve the last one. The solution will be shown in the end.